So now we're going to calculate some of our, I figured out how to use my calculator, and we're going to do some of our practice problems that you guys got on Friday. And I'm going to refer back and forth to this set of equations. Okay. This is the most standard calculation that I've seen people use in scientific reporting. However, you kind of have to know how to do all of it because you never know what you're going to get. Okay, so we're going to start with this right here. And let me get you in. Let me get autofocus. Oh, it isn't supposed to be an autofocus. Darn it. It seems to be jumping around. Okay, so the pH from the hydroxide ion concentration. Okay, the pH is negative log. Remember that logarithmic scale is that nonlinear scale, so it's an exponential scale. Okay, so a negative log of the hydrogen ion concentration. So basically, I'm going to figure out how to do negative log of 7.5 times 10 to the negative 6. Okay. Everybody's calculator is a little bit different. Actually, I think you guys all might have a standard calculator. I do not have one of those calculators. So I have to put mine in like this. 7.5 EE, which is probably standard what you guys do, that whole EE 6. Then I have to do log, and then I take the negative of it. So it's 5.1. Okay, 5.12. That's the pH. Alrighty. Hopefully you can identify that as being acidic. The other thing I want you to think about, in case somebody ever asks a question like, is this acidic or basic? Without doing that whole calculation, remember, in a neutral solution, pH of 7, the hydrogen ion concentration is 1 times 10 to the negative 7th. This is greater because it has less decimal places, right? This is greater than this. So since it has more H pluses, you should know it's acidic. You're not going to know how acidic unless you're really good at figuring all of this out. But you should be able to identify that it is acidic because this number here is bigger than that number there based on the exponents. It's not based on this number here. It's based on the exponents. This has fewer decimal places. Okay, let's do this one right here. Calculate the pH and the pOH of a solution of a hydroxide ion concentration. Okay, this is where one of the things that I do think it's easier to use the pOH because this conversion here is very easy. So pOH equals negative log of hydroxide ion concentration, which is negative log of 3.6 times 10 to the negative 8 moles per liter of hydroxide ions. So I'm going to do 3.6 EE negative 8 log negative. So the pOH is 7.44. Okay, be careful with this. This makes it, you may think this is basic. No. The pOH is 7.44. So that makes the pH is, remember the pH plus the pOH, make that a plus, is 14, right? So if this is 7.44, this is going to be, I think, 6.56. Let me make sure I'm doing that right. 14 minus 7.44, 6.56. My arithmetic is still good. So pH is 6.56. Now it becomes abundantly clear that's acidic. Okay, if you can remember what's acidic, 1 through 7 in pH, and then 7's neutral, so 1 to anything before 7 is acidic. Okay, so this question asks for pH and pOH, so you would have to identify both of them. Okay, and let me see, I think there might be one other type of question here. Okay, let's do number 5, and then I think you guys can do, no, let's do number 4, and then you can oh wait, no, we'll do number 3, and then you can do 5 through 8 if you haven't already done it. Okay, remember pH equals negative log of hydrogen ion concentration. Okay, but I have this instead. How do you go backwards? Remember, this is an exponent. So the hydrogen ion concentration is 10 raised to the negative pH, or 4.58. Oops, I should have practiced this before I started this. See if I can remember how to do this on a calculator. Um, second function, log. Okay, you probably already know this, but if you don't, your second functions are usually the inverse of the function on the button, right? So the inverse of a logarithm is 10 raised to, because remember that log is an exponent. So we're going to do second function log negative 4.58. Oopsie, I think I got it in there wrong. Let's see. I bet I have to do this. Negative 4.58 second function log. There we go. 0.0000263. I think I got 1, 2, 3, 4. 1, 2, 3, 4. And you probably know this already. I should have three significant figures. Three significant figures. So it should be 2.63 times 10 to the what? 1, 2, 3, 4, 5. 10 to the negative 5. That's its molarity of hydrogen ion concentration. So that's the answer. That's how you do that problem. Okay, so I think you guys weren't complaining that you didn't know how to do this, but hopefully if anybody was struggling, hopefully this is helpful. I think this might be my last video. If anybody has any questions about other things going on, certainly email me. I will answer it, and then we can talk on Monday. I hope you guys have a good weekend.